When dealing with large configurations, two key problems exist. Traffic management attributes need to be repeatedly configured across all objects, and changing settings across these objects can be tedious and complicated. Profiles are a powerful configuration tool, providing an easy way to define traffic policies and apply these policies across virtual servers. This section does not have any labs, but profiles are used in later labs. This section is harder to teach than most since it introduces a concept that is more abstract than many. One idea to illustrate profiles, the matrix. Neo needs to learn jujitsu, but rather than training for months, they sit him down and plug him into a martial arts program. Voila, a master. Virtual servers learn HTTP the same way. An HTTP profile tells the virtual server what a cookie is, what a method is, how to read HTTP headers. Dependencies, using the example above, if a virtual server wanted to process a cookie, it would need an HTTP profile, which would need a TCP profile. Types are groups to make it easier to find them. Some based on layer 7 FTP, HTTP, some layer 4 UDP, TCP. The goal is to let the virtual server slice and dice the data stream many different ways. Configuring. Profiles are a little different than other objects created at this point. Profiles define how the admin wants the virtual server to process traffic. Encryption, compression, search and replace, some of many abilities of profiles. Customizable and repeatable, since you can associate a given profile with many virtual servers. Some of the templates can be used in production, contrary to recommendations for monitors. Certainly TCP, HTTP, FastL4, and FTP can often be used in production. Persistence profiles define methods that the big IP system can use to treat multiple TCP connections as a single session. Persistence, load balancing the first connection to a given client and sending subsequent connections from the same client to the same pool member. So question, how do you identify a client? This is the reason for multiple persistence profiles. Typically, the client-side and server-side traffic are separate TCP connections. One being SSL doesn't require the other to be. LTM can be the server on the client side and then send traffic unencrypted to the servers. This reduces the load on the servers. When a user connects to an FTP server and downloads a file, how many TCP connections take place? Who initiates them? In active FTP, the client initiates a connection to port 21 for command and control, but the server initiates the data transfer connection from port 20. Why does LTM let the pool member initiate this connection? The FTP profile. It examines the port 21 connection, sees the port command from the client, anticipates the server initiating a connection from the client's IP and the designated port. Without the profile, server SYN would be dropped. In passive FTP, the client initiates the connection to the port the server has specified with the conversation in the port 21 connection. This client connection is initiated to the LTM to an address port that does not match a virtual server. Yet it is processed due to the FTP profile. The OSI model seems to be the best way to explain why certain profiles require other profiles when configuring the virtual server. If you are using a higher level profile in terms of the OSI model, the lower level profiles will be required config for that virtual server. Similarly, two profiles on the same layer cannot coexist. These groups are more administrative than anything else. There are lots of types of profiles. Base profiles are stored in profile_base.conf, a read-only file. If changes are made to the base profile, The modified profile is stored in bigip.conf. If the modified profile is removed from bigip.conf and bload command is run, the system will gain the use of the base profile in bigip_base.conf. If the profile is removed and the system is rebooted, the profile will still be modified from the SCF. After the reboot, a bload will revert the system to the base profile. At a minimum, every virtual server must reference a layer 4 profile, such as UDP, TCP, or fast layer 4. Reject virtual servers may not have a profile. There is no option to assign one or change one. But since defaults aren't listed, the configuration file cannot confirm this. Through the GUI, the default profile is TCP. Through the CLI, the default is FastL4. Profiles can be created multiple ways. Clicking the Create button is one, but often leads to creating a service profile, mainly because when you click on the profiles, it's going to take you to the first tab that's on the top. So you just have to be careful to make sure you click on the right tab and which profile you want to create. Some of the best way to create a profile is usually if you click profiles over here, and then in the little flyout menu, you click whichever type of profile, protocol in this case, and then you could click your TCP, UDP, or whatever else. For the child, if the custom box is checked, the change from the parent will not affect the child. If the value for the parent changes, i.e. timeout, the child profile does not have the custom box checked, then the child profile will use the new settings of the parent. On the contrary, if the child profile has the custom box checked, even if the value is initially the same as the parent, if the parent later changes, the child will not automatically change.